Hi, welcome to what would have been lecture 19 on March 31st. So let's get to it. So the opening track for today would have been Instant Attraction by Brian Hazelbauer. Cue it up, take a listen, and the question is, what does that have to do with today's lecture, I should say. And it turns out that it is the attraction that is the link. So what are we talking about today? Well, so we're talking about the intermolecular forces that actually hold molecules together to form liquids and solids. So we're not talking about the bonds within molecules, but the attraction from molecule to molecule to bring compounds together. So with today's lecture, there are three of them. You're going to talk about, we're going to relate the structures that are within molecules to the intermolecular forces that are present, and there are three such forces. And finally, we're going to learn how to predict trends in macroscopic pressure, such as boiling point and vapor pressure. And all of these are aligned with the course learning outcome number 8, which is explaining the intermolecular attractive forces that determine physical properties. And we're going to apply this knowledge to qualitatively evaluate the forces and predict the physical properties that result. That will be over the course of a couple of these lectures. All right, so had we been meeting in person, you would all be looking at a handout with this information right here. So what I've got here is just a bunch of compounds. And they're in three groups. This thing called alkanes, this group called ketones, and down here this group called alcohols. And what I want you to do is think about, first of all, look at the structures in each group and kind of see what they have in common and what the defining structural feature of each group is. And just because you haven't seen this a whole lot. What this formula means is that these lines represent bonds between carbon atoms. And if you see something like, C and then H2 or something like that, that implies that both of these hydrogens are attached to this carbon, and that this carbon is also attached to this carbon and that one. This is just a shorthand, so you don't have to explicitly draw out the complete structure. And I think with that, you've got actually the information that you need. And I've got here the molar mass of each compound listed and its boiling point in degrees Celsius. And there's also a hint on the side panel that I haven't talked about yet. So hit pause, take a look. All right, welcome back. So what makes a particular molecule a ketone is the presence of this group right here. The carbon-oxygen group. What makes something an alcohol is this OH group right here. And more specifically, I'll draw it right here. There's a carbon that has stuff bonded to it. It is singly bound to an oxygen. It's got 2 lone pairs on it. And then it's singly bound to a hydrogen. Right. And the presence of that structural feature is what makes something an alcohol. And finally, the defining feature of an alkane is that, well, it doesn't actually have a defining feature, that it has exclusively carbon-hydrogen bonds, and they're all single bonds. All right, so the next task is I want you to look at each group individually and see how the boiling point changes with mass within a group. And then I want you to think about what that implies about the intermolecular forces. So these intermolecular forces, in this case, they're all attractive, and they are bringing molecules together close enough to form a liquid or a solid, depending on the temperature. So how do you think that changes with boiling points. So what I mean there is, think about if something has really strong intermolecular forces, does it have a high boiling point or does it have a low boiling point? So try to piece these together and then answer these two questions, and these are really simple to answer. It should be just, it goes up with mass or it goes down with mass, and the intermolecular forces get stronger with mass or they get weaker. All right, so take a look. And all right, hopefully you've had a look. So the trend with all three groups is that as the molar mass increases, the boiling point goes up as well. So the implication here is that if the boiling point is going up, the way that something boils is that those intermolecular forces are broken. Remember, the hallmark of the gas phase thing is that there are no interactions, whether they're attractive or repulsive, between molecules. So if the boiling point is going up, that means that for a boiling point to go up, this means you have to put in more energy to break these intermolecular forces to form a gas. So the implication there is that these intermolecular forces are, by extension, getting stronger as molar mass. So usually, and this is a big deal, and typically boiling point is actually used as a gauge of the strength of the intermolecular forces. Okay, so now the next thing that we want to do is figure out what effect the various structural groups have and which one might have the strongest intermolecular forces. So the way we're going to do that is we're going to analyze 3 compounds, one from each group, with similar molar masses. Now we just determined that the molar mass has an effect on the boiling points, so we want to control for that. So let's pick one member from each group that have fairly close molar masses. So for example, we could do pentane over here. And let's see, that has a molar mass of about 72, as does 2-butanone. And if we're looking down here at the alcohols, 1-butanol here clocks in with a molar mass of about 74.1, and that's close enough. So what you want to do is, look at these and see how does the boiling point change across each group. And what you find is that, which one has the largest one or the highest one? Which one has the lowest one? And with this pair, the alkane, the pentane, has the lowest boiling point. The alcohol has the highest boiling point, and the ketone is in the middle. So with that in mind, let's ask ourselves, how did the strength of the intermolecular forces change? And it's going to be a similar progression. Remember, the higher the boiling point, the stronger the intermolecular forces. And that tells us that the alkanes have the weakest intermolecular forces, the alcohols have the strongest, and the ketones are in the middle. And it really wouldn't matter which set of 3 compounds you looked at, that as long as you had the molar masses were similar, that is always the order that they're going to fall under. So this implies that, again, the alcohols have the strongest intermolecular forces and the alkanes have the weakest. So in the next video coming right up, we're going to talk about specifically the nature of those forces. So see you then.